In this video, you will learn how to deploy a sentiment analysis machine learning model on AWS Lambda with Python, Docker, FastAPI, and ONNX. In this tutorial, I will teach you how to create a Lambda URL endpoint that receives a text like "I love this product" and returns if the sentiment is positive or negative. In this case, it's positive, but it can also receive a negative text like "I hate this product." Okay? By the end of this video, you will have a Lambda container deployed on AWS using a Docker image, and you can serve predictions using function URL. You will have a function URL with a route called predict, okay? And you can make a HTTP post request to this endpoint passing a text. In this case, I pass "I love Brazil", so it returns a positive sentiment. Hey gurizada, I'm Matheus, a Brazilian software engineer at Itaú, the largest private bank in Brazil, and I started this YouTube channel to share what I'm learning about AI and to improve my English skills. So, if you spot a bug in my code or in my English, let me know. Suggestions are always welcome. Bora aprender juntos, let's learn together, and let's start the tutorial. This tutorial will have three parts. The first part is to download the model. The second part is to build the code and predict it locally, okay? And the third part is to deploy the model on AWS. The first part to download the model is to download this model. This is the model that we are using, okay? It's a sentiment analysis model that I showed you before what it does, okay? And to download it, you're gonna enter in the GitHub app of this tutorial, and you're gonna go to download model folder. Inside this download model folder, you have two options to download the model. You can download this folder here, okay? And this folder has all the files you need, including the ONNX model. This model is already quantized, okay? In a very simple way, quantize a model is to compress it. Or you can execute these 4 Python scripts to download and quantize the model. I'm not going to do that here, but it's very simple. And if you have some problem, you can follow this README, and in this README show you how to download and quantize the model. To go to the next part of the tutorial, you need the downloaded model. So download the model and let's go to the part 2 of this tutorial. So let's start our tutorial. The first thing you need is your model folder, okay? I will paste it here. I told you how to download it before. Now that we have our model, we're going to create the directory structure of our project. The first thing is to create a new folder called Sentiment Lambda, okay? Inside Sentiment Lambda, we're going to create a folder called App. Inside App, we're going to create a folder called Model. Inside the model folder, we're going to put our model, okay? Inside Sentiment Lambda, we're going to create a requirements.txt folder. I will copy and paste the requirements here, okay? So with the requirements in our requirements file, we're going to create a env environment, a venv environment. So Python 3.m vm.vm. So before that, we need to enter in the folder for the VM environment is cd sentiment lambda, okay? So now we're going to do python.mvm.vm. Oh, Python 3, sorry. It's creating the VM. Okay, now we're gonna enter in this VM folder. So to enter, we're gonna do source.vm.bin/activate. So now we are in our VM environment, and now we can do pip install.r requirements.txt. While it's installing our package, we're going to start creating our code. The first thing we're going to create is a file called predict.py, okay? And what we're going to do here, we're going to make a function that predicts, of course, that receives a text message and return the sentiment. So here we're going to create the function that loads the model, okay, and use the model to predict the sentiment of a text, if it's positive or negative, okay? So to start, let's first import the libraries, okay? So from pathlib import path. We're going to use pathlib to handle easily with the paths to the path that specify our model. We're going to import nump as np because we're going to use nump arrays because the model can be exported in NumPy arrays, and I prefer to use NumPy arrays to do that. So NumPy, it's a numerical computer library. Probably you know that if you're watching a machine learning tutorial, okay? But if you don't know, don't worry, it's easy. For this tutorial, of course, not easy. We're going to import ONNX runtime as port. This is what we're going to use to load the model in our memory and to run the model. And from transformers, we're going to import auto tokenizer, okay? This we're going to use to create tokenizer, and this tokenizer will create tokens. It will take the raw text that we receive. Sometimes I look into the webcam, I don't know why. Okay, so this will take the raw text that we receive and transform it into tokens. I will minimize the recorder screen here so I don't stay looking there. Okay, so first things first, start with the base dir. Okay, so the base dir is where we are. So we're going to create a model dir. This model dir is base dir./model. Here we're going to specify where our model is. Your model isn't in the model folder, it's in model, and it's /1nx model. Oh, sorry. Next model quants, okay? And we also going to specify where the ONNX file is. So it's inside model dir, but it's model quantized. So here we're just specifying where our model folder is and where our ONNX file is. Okay, so here is our ONNX file. So the first thing we're gonna do is to load the tokenizer. Okay, so tokenizer. What the tokenizer does? We are going to use the tokenizer to tokenize our raw text. Okay, so it transforms text into tokens, more specifically into numerical IDs that represent these tokens. Okay, so our tokenizer from pre-train here, we're going to specify our model dir. Okay, so model dir, and here we're going to use a flag that's local files only. Okay, because sometimes it can try to take files from the repository, from the model repository, and we don't want this. Okay, so local files only go through. Okay, it's correct. And before load the tokenizer, we need to load the runtime session. We need to start a runtime session. So we're going to create a variable called session, and we're going to do this arc inference session string ONNX file provides CPU execution provided. What it's doing here, we are loading our ONNX model inside the memory of our program. Okay, it make a suggestion here. I think it will work, but I will do with another way. Okay, that's as POSIX. Okay, I prefer to do that because I already tested. Okay, but I think that will work with the string parameter. Okay, so after do that, we're going to do one more thing before we start making our section. That's labeling what value return is positive and what value return is negative. So we're gonna create a id2 label, okay? That 0 represents negative and 1 represents positive. So why are we doing this, okay? If you enter here in config.json inside our model, you see that 0 represents the negative class and 1 represents the positive class. Okay? And what it's saying? It's saying that the first element of the returning array when we make a prediction, it will be represented the negative class. And the second value will represent this positive class. We are using a binary classification model, so we can just have two options. Or it will be the negative class, or it will be the positive class. Or the sentiment will be negative, or the sentiment will be positive, okay? So, with that in mind, we're going to start to create our prediction function, okay? Now it's the moment. So, predict, it will receive a text string, okay? I'm not going to say what it will return. To start, we're going to start tokenizer. So using the tokenizer that we built before to, we are encoding, okay? So we are transforming our raw text into numerical IDs, into tokens, okay? And I like everything here. I don't want this padding parameter, okay? Max length, okay. Return traces NP, truncation true. And this is the parameters that I want to use, okay? So basically it's taking a raw text and transforming into numerical IDs and attention mask, okay? So now with the encoder text, we can do we can make a prediction. Yes, we already can make a prediction. So logits equals session run, okay? And the first parameter we're gonna say that's none, and the second one we're gonna say that adject of encode, okay? And instead of -1, we're gonna say 0, okay? So to explain to you what we're doing, we're taking the model that we load inside your program, okay, into the memory of our program, and we are making the prediction, use the tokens that we use the text that we transform into tokens. So I'm gonna print logistics to you understand the logic, okay? So I'm gonna text, I don't need this, I'm gonna predict, okay? And this is a great movie, I really like it, okay? So with this, you're gonna understand what we are doing. So I'm gonna enter inside our app folder, okay? And I'm gonna say Python predict.py. So everything is okay, we are predicting now. So what this array, okay? I said to you that we have two classes, the negative class and the positive class. So the first value represents the negative class. The second value, that's represented by 1 because its array represents the positive class. So here, there is two values. The high value represents what the model think is the class. So here the model think it's positive, and it's correct because this is a great movie. I really like it. It's a positive sentence. For you to understand better, we can try to create a negative example. This is a bad movie. I really don't like it. Okay, so let's try to create a negative example. It will return two arrays. Now you can see that in negative, the first value is higher. So this is how we know which class we represent, okay? So with this, you can already make the model, you can already deploy it to AWS, and you already make sentiment analysis. I want to do one more thing, then I want to know the probability, okay? I'm not going to explain here this exactly, but we're going to use a softmax function, okay? So I'm just going to paste the code that I'm going to use here because I'm not going to explain. And what it's doing, it's taking these logits values and it's applying a softmax function, and this will return the probability, okay? So the array of the probabilities works in the same way. So what we're going to do, the prediction is the higher value probability, okay? So the value with the higher probability is the correct value. So we're gonna say the idx int probs dot argmax, okay? And we're gonna to return two parameters, the to label with the idx that represents the higher class, so the higher value, so the higher value represents the correct class, okay? And the second parameter, it will be float, okay? Probs dot max, and this return the probability. So let's test our function to see if it's correct, to see it's working. This is a test sentence. It's not a good test sentence. Let's say I love this movie, okay? And let's print test. And let's see what happened. So you can see that I love this movie. It's positive, and there is a chance of 99% of being positive. Né? This is the estimation of the model. So we create our predict.py function. So with this prediction function create, we're gonna to delete these two lines, okay, to erase these two lines because we're not going to need it. And now we're going to expose our function in an API, okay, and we're going to expose it with HTTP edge points, okay. So to do that, we're going to use FastAPI. So I'm going to create a main.py because our Lambda going to enter inside this folder, and we're going to start import the library. So first from FastAPI, import FastAPI, okay. From Pydantic, import base model. FastAPI is the framework, the web framework that we're going to use to make the HTTP endpoint. I talking Portuguese and English in the same time. It will be fun to watch this video later. But anyway, it's HTTP endpoint. I think my English is the best. Okay, sorry for that, guys. From Pydantic import base model. From predict import predict, okay. I'm also going to do one more thing here. I'm going to create a init.py file to specify to Python that it's a package, okay. It's a better practice, I think, okay. Like I said too, I'm not the expert. I'm just trying to share what I'm studying with you, okay. And from Mango, import Mango. Mango, it's a library that it's a Lambda adapter, okay? It will make it easy to handle with Lambda requests when we deploy our model. First thing we're going to do is create the request. Our request, it will be just a simple text. So our endpoint will receive a text. The second is to start FastAPI. And we're going to do a route, okay? That's called predict. Def route, we're not the best name, but we're going to use it here. Request, okay? And it make a function for me. I think it's something like that I need, so I'm going to fix it. So label, we're going to call it sentiments, okay? We also want to return the text, so the request.text. Probability, we're gonna call prob, and this is the function. It's correct. So what are we doing here? We are using the function that we built before and returning the values that we're making a prediction. So to remember what this function do, it receives a text, okay? It transforms this text into tokens, okay? more specific into IDs, annotation mask. Use these IDs annotation masks to make a prediction. Use the model that we specified before, and returns if the text has a sentiment, that has a positive sentiment or a negative sentiment. Okay, it's what it's doing. Before we finish here, we need to use Lambda handler, use Imago, because it will make it easy to make HTTP requests. Guys, it's another day for me, and I forgot to do one thing, okay? We need to import predict as part of the app package. To do that, we're going to add a dot here, okay? So with this adjust, I don't know how to say this in English, we're going to test. To test, we're going to use uvcore, so we're going to write uvcore. Oh, before that, you need to enter in the sentiment lambda folder, and now write uvcore app.main/app reload, okay? And I'm gonna copy here the cool request that you're gonna make, okay? So you're gonna make a request to this endpoint. I'm going to create a new terminal here, and I'm gonna make the cool request, a post request, with the text being "I love this app," so it should be positive, okay? The sentiment is positive, and now we're going to the next part of our tutorial, that's creating the Docker file. So let's create our Docker file. To create, it's going to be inside our sentiment lambda folder, okay? So inside sentiment lambda folder, we're going to create a new file. We're going to call it Docker file. I'm going to copy and paste here the lines, okay? And explain to you. The first line we are using the official AWS Lambda image, okay? Here we are copying to the image our requirements.txt, so we are importing our dependencies. Here we are running and installing our dependencies. Here we are copying the app folder that contains our code, okay? And this probably is the most important part, that we are initializing the Lambda handler, okay? Using Magnum, like I said to you before. So to test it locally, the first thing we need to do is to run to build our Docker image. So Docker build, I'm gonna use no cache, okay? .t, we're gonna call it sentiment lambda. We're gonna tag it as sentiment lambda and run it, okay? So it's gonna run, and after that I come back here. To run this locally, there is a very cool thing that's called runtime interface emulator. This image from AWS has this runtime interface simulator that when you run it, the Docker image behaves like a Lambda, okay? So we're gonna run this Docker run, okay? And make sure to pay attention to the ports, okay? And sentiment Lambda, that's our image. And we're gonna run our image, okay? Using the runtime interface emulator. So our image is running, and now we're gonna test it. There is a catch here, because Lambda don't expect like the raw JSON. Don't expect the JSON. It expects a event object, and this event object is created with API gateway or with the Lambda URL. That is what we are using inside this tutorial. So I'm gonna inside this create a new file that I'm gonna call it I'm gonna call it events.json, okay? I'm gonna copy and paste here. So this is our event. So this is the kind of event that the Lambda expects. And after that, I'm gonna make a cool request using this event. So I'm gonna open a new terminal here, and I'm gonna make a cool request to our Docker image, okay? So see here that we're passing our event.json with this cool request, okay? And this is the cool request that you need to do to the Docker image behaves like Lambda. So it starts code 200, so probably it's correct. You can see here that it returns the sentiment that is positive, and you can see that the text that we pass is absolutely Love this. Okay. So now we test our Docker image locally, and now we can deploy it to AWS. So to deploy on AWS, the first thing you need to do is to create an Elastic Container Registry repository. You can do using AWS CLI, or you can do on AWS console. Here I'm going to create the repository on AWS console. Okay. So to create, you're gonna enter on the AWS console. You're gonna search for Elastic Container Registry, and you're gonna create a repository. Click on create, and you can say sentiment lambda. Okay. Leave the things like that. Create. So now you have create your ECR repository. So with your ECR repository created, now you can deploy our image to our Docker image to AWS. To do that, first I'm going to create a uchoose.txt file just to copy and paste the comments that we're going to use to deploy our image to AWS. Okay. So the first thing you're going to do here in Linux is to set some variables to run our commands. Okay. So region, you're going to use yours, of course, the one that you want to use on AWS. Account ID, you're going to use yours again. And sentiment, you're going to use the repository name. So sentiment lambda. So I'm going to set these variables. Okay. Of course, to do this part of tutorial, you need to have AWS CLI styled, okay? And we're gonna run the first command that is to authenticate in ECR, okay? So it's using AWS CLI, and it's using my credentials that are already installed, okay? After that, we're gonna build our image, okay? So it can take a little bit. It's cached from the memory, so I'm gonna leave like that. But if you want or prefer, you can use no cache, okay? No cache. After that, we're gonna tag our image, and now we're gonna push the image to the ECR repository. So it can take a little bit again. So now we are going to enter on AWS console. Okay, let me find it here. And you're gonna enter inside your repository, and you need to see an image inside that. So we upload our Docker image. So with our repository created and our image uploaded, we can create our Lambda function. So we're gonna search for Lambda, okay. Gonna go on Lambda, click on create a function, container image, okay, sentiment Lambda, container image UD browser, okay, select your repository and select the image that we upload. Additional configurations, we're gonna use a function URL, we're gonna use auth type none, okay, just for testing purposes, take care of that. We're gonna configure cross-origin resource, okay, and this is the configuration. You can click on create function, and it's creating. I hope so. The function is create. We need to do some configuration, okay. The first configuration is with the memory of our Lambda, okay. You can read here, but it's a thing that you must know about Lambda, that your function is allocate CPU proportion to the memory configured. So if you improve the memory, you improve the CPU. What we're doing, we are deploying a machine learning model inside the Lambda. So we need, and this machine learning model, we configure it to use CPU. So we need a lot of CPU. So To start, I'm gonna use 1024. You can test uh, less, more. You can do improves on your code to use less, okay? But I think it's a good number. And we're gonna use a timeout of 10 seconds, okay? Take care of it. Like I said to you, we did just the basics in our configuration, in our Lambda. There is a way to improve it, but to start to this tutorial, we use 10 seconds of timeout, okay? And it's updating the Lambda function, okay? So the first thing you're gonna do is do a basic test. We're gonna open our function URL, just clicking on the URL, okay? And it do a basic test. The expect output is not found because we don't configure any route for this. There's one thing I need to tell you, that I already have done this before start recording this part. So it take a little bit less than it will take in the first time because Lambda has something called cold start. Probably if you're watching this tutorial, you know that. But if you don't know, search on ChatGPT or on Google Lambda cold start to understand better, okay? So now we are going to really test it on VS Code. So to test it, we need to do a pull request to this URL. So I'm gonna copy this URL, okay? And I'm gonna go to my VS Code. Okay, I already pasted here the pull request that we're going to do, but I will change the URL with our URL, okay? So if we copy it and paste it, it should work. So we made it, we finished it, okay? There's some adjustments you can do, but the idea is that we make a pull request to with I love this product, and it returns a positive sentiment. Let's try I hate this product. So the sentiment is negative, okay? So we made it. We deploy a machine learning model on AWS. So in the beginning of the tutorial, I show you a HTML page that make the request to the Lambda URL. I'm gonna paste this HTML page here, not inside the app folder, sorry, inside the sentiment Lambda folder. And I'm not going to teach you how to create this page, but I'm gonna show you how you can use your Lambda URL here, okay? So to do that, first you need to copy our endpoint, okay? And go here and look for endpoint and change to our new URL, okay? So here is the only configuration you need to do. You also need to do some coarse configuration. So to make the function URL work in the HTML page, you need to do the coarse configuration. You're gonna go to function URL, you're gonna go to edit, and here you're gonna allow all oranges, okay? In allow here headers, you're gonna say content type, okay? In allow methods, you're gonna select all, and here you can leave it blank. Click save. So with this configuration, your Lambda URL should work in your HTML page. So let's try it. So this is the HTML page. Let's try I love this page. It make the request. It is taking a little bit because of the cold start. And the sentiment is positive. Let's try I hate this page, okay? The sentiment is negative. Let's try I hate this product. So now we officially finished the tutorial.